Welcome to this video that belongs to Lesson 2 of Module 2. My name is Mari Carmen Suárez de Figueroa Baunza, and the aim of this video is to define the ontology conceptualization activity and to present methodological guidelines for performing such a conceptualization. We start by defining the ontology conceptualization activity, which refers to organize and structure the information, data, and knowledge which has been obtained during the knowledge acquisition process. The results of the conceptualization activity are models at the knowledge level, according to the ontology requirements. It is important to mention that the conceptualization activity is independent of the way in which the implementation of the ontology is done. Now, we show several issues to be considered during the ontology conceptualization activity. There is no single right way to model a domain. That is, there are always alternatives. The best solution almost always depends on the application that you have in mind and the extensions that you anticipate. Here, there is a relation with the ontological requirements. The elements of the ontology should be close to physical or logical objects and relationships in the domain to be represented. Normally, they are nouns for objects or verbs for relationships in sentences that describe the domain. In addition, it is important to use naming conventions when providing names for the ontology components. For example, concepts in capitals, relationships and attributes in lowercase, among others. Now, let's talk about some considerations to take into account when modeling classes and class taxonomies. It is worth mentioning that classes represent domain concepts and not words denoting such concepts. Thus, synonyms of the same concept do not represent different classes. With respect to class hierarchies, a subclass represents a concept that is a kind of the concept represented by the superclass. In addition, if a class A is a superclass of a class B, then every instance of B is also instance of A. For example, apple is subclass of fruit because each apple is a fruit. Red wine is a subclass of wine because each red wine is a wine. And Chianti wine is a subclass of red wine because each Chianti is a red wine. However, a particular person is not a subclass of every person. When modeling hierarchies, it is a good practice that all the sister classes in the taxonomy have the same level of generality. In addition, subclasses of a class normally have additional properties that the superclass does not have, different restrictions that the superclass does not have, and participate in different relationships. It is also important to include disjoint and exhaustive knowledge in concept hierarchies. To model class taxonomies, it is important to follow the following recommendations. If there are more than a dozen of subclasses for a class, then you need to review the model because an intermediate class may be necessary. If a class has only one direct subclass, then you need to rethink the model because there may be a modeling problem or it could have model incomplete knowledge. We know that classes are unary predicates, that is, they can be compared to questions with a single argument. For example, is this object a wine? However, properties are mainly binary predicates, that is, they can be compared to questions with two arguments. For example, is the flavor of this wine strong? Or what is the flavor of this wine? With respect to properties and class taxonomies, it is important to mention that properties are inherited between classes. A subclass inherits all the properties of the superclass. For example, if a wine has a name and a flavor, then a red wine has also a name and a flavor. If a class has multiple superclasses, then such a class inherits properties from all of them. When properties are modeled, we must choose the most general class in the taxonomy, that is, the class involved in the relationship that is at a more general level in the tree representing the class taxonomy. When talking about properties, relationships or attributes, it is necessary to define the domain and range. Domain refers to the class whose role is to be subject of the property, and range refers to the values of the property. For example, the wineries produce wine. In general, you can compare the domain with the origin of the relation, in this example, winery, and the range with the destination of such a relation, in this example, wine. As already mentioned, when domains and ranges of properties are defined, you must find the most general class or classes involved in the properties. For example, the domain of property taste should be the class wine and not the classes red wine or white wine. And the range for the relation produces for winery should be the class wine and not the class red wine or white wine. Some general rules that can help you to select domains and ranges of properties during the ontology conceptualization are: if the property can be applied to a class and a superclass in the same taxonomy, then you should use the superclass. If the property can be applied to all the subclasses of a class, then you should use the superclass. And finally, if the property can be applied to most of the subclasses of a class, then you should consider using the superclass. Now, we will see a summary of what is presented in this video. We recommend you to stop and summarize what you have seen in the video. I'm going to continue, but it is recommended that you stop and write the summary. The ontology conceptualization activity refers to organize and extract knowledge in models. There is no unique right way to model a domain. That means there are always different alternatives. Ontology elements should represent objects and relationships in the domain. You should find names for the objects and verbs for the relationships in the sentences that describe the domain. Classes represent concepts in the domain, thus synonyms of the same concept do not represent different classes. And a subclass of a class represents a concept that is a kind of the concept represented by the superclass. Subclasses of a class normally have additional properties and different restrictions, and also participate in different relationships. Properties are inherited between classes. A subclass inherits all the properties of the superclass, and if a class has some multiple superclasses, then it inherits properties from all of them. Finally, the properties have domain and range, which should be defined using the most general class or classes to which the property can be applied. Finally, it is advisable to review the additional material available on the platform. Thank you for your attention.